Hello students, I thought I would just give you some tutorial videos to show you what we're doing. I know sometimes in chemistry it would be pretty hard just to look at the book and try and figure it out yourself. So if you remember last time we were doing things, we were talking about an energy change. And an energy change, we call it an enthalpy. So an enthalpy change, and you'll hear me say that a lot. That's an enthalpy change. Now when we talked about energy in a chemical reaction, we talked about the units too. The units for an energy change is joules, abbreviated as a capital J. Now that's a really small unit, so a lot of times we'll use what's called a kilojoule, and that's just 1,000 joules, of course. And then we talked about endothermic and exothermic chemical reactions. We did the delta H. We talked about how delta H was either negative for an exothermic reaction or delta H was a positive for an endothermic reaction. So that's just a real quick review about what we've been doing. So today what we want to talk about is something called Hess's law. And this is nothing that we've ever done in regular chemistry either. So I'm going to be on page 269 in your textbook. If you want to read Hess's law, right there you can. I'm just going to paraphrase it real quick. It says that if there's a single chemical reaction, you can calculate the either heat absorbed or given off by a single reaction. If a reaction occurs in more than one step, you can add those chemical reactions together to get the total enthalpy change for a chemical reaction if it all happens at the same temperature. Now I'm going to show you the applications of this and the problems that we're going to be doing with Hess's law while we do this. So first of all, there's a couple of things you need to know for Hess's law. Number one thing is if you reverse the reaction, you also need to reverse the delta H. So I'll give you an example of that, show you how to do that right now. So if we have an equation, for example, here's an equation where we have H2 gas plus 1/2 O2 gas goes to make H2O gas, and we have a delta H that equals a negative 242 kilojoules. Now if we reverse the reaction, in other words, we're going to take the H2O, the products, and put it on the reactant side. Now this reverse reaction now becomes H2O gas, H2O gas yields, on the right side, it's just going to be everything from over here, yields H2 gas plus 1/2 O2 gas. And the delta H, if we reverse the reaction, we have to reverse the sign. So this sign now becomes a positive 242 kilojoules. I know we haven't talked a lot about reversible reactions, but we can reverse reactions too. And also, don't be too worried about this 1/2. So instead of putting a 2 here, a 2 here, and a 1 here, a lot of times they just put a 1/2 in front of that, and just so there's not numbers in front there. So that's what that 1/2 means. So that's a reversible reaction, or when we reverse a reaction, we just have to remember to reverse the sign and just flip the products and the reactants. Number 2 says whatever you times the equation by, you also have to times the delta H by. So let's do this equation that we just did right here. So we have H2O gas goes to make H2 gas plus 1/2 O2 gas, and the delta H equals a positive 242 kilojoules. Okay, now what we're going to do is we're going to take that reaction, and now we're going to times everything by 2. So we're going to times the whole equation by 2. So now we have 2 H2O gas goes to make 2 H2 gas, plus 2 times 1/2 is just 1, so we're just going to have O2 gas. And the delta H, now we're going to times that by 2, is also a positive 484 kilojoules. Okay, so we just times whatever we times all the equation by, we also have to times the reactants by. Okay, so that's important things to remember when we're doing Hess's law. Okay, now I'm going to give you an equation here. We're going to do an equation here and combine it. So here's the equation. It's solid carbon plus 2 H2O gas goes to make CO2 gas plus 2 H2 gas. All right, so this is example problem. So this is example problem 9.12 on page 269 of our textbook. He gives us this equation right here. Now what we're trying to find out is what is the enthalpy change, or what is the delta H for that equation. So now we're going to have two different equations that it's going to give us. The first equation is solid carbon plus O2 gas goes to make CO2 gas, and then it gives us the delta H. Delta H equals a negative 304 kilojoules. Okay, so that's our first equation. Our next equation is H2 gas, and this is the same one I just wrote above, plus 1/2 O2 gas goes to make H2O gas, and the delta H for that equals a negative 242 kilojoules. Now what we're going to do is we're going to add these two equations together to find out what the delta H is for that. So, but before we do that, before we can add these together, we have to make sure that they're the same as they are in the original equation. So we're going to look at carbon. It's a solid. There's one carbon. We're also looking to see if it's on the left side of the equation, which is it. Up here it's on the left side of the equation. Up there it's on the left side. So they're both on the same side. O2 is not even in that equation anywhere right there. So there's no O2, so we're not even going to worry about that. Over here we've got CO2 on the right side of our equation, and up here it's also on the right side of the equation. And there's one of them, and there's one of them, so that is good. We're not going to do anything with that. Going to the next equation, we look over here on the left side, we have H2 gas on the left side of our arrow. Up here, our H2 is on the right side of the equation. Oxygen we're not going to worry about. H2O is on the right side of the equation. Up here it's on the left side of the equation. So I know that I have to flip-flop that equation right there. So I have to reverse it. So I'm going to reverse the whole equation right here. So now this equation turns into, over here we've got H2O as a gas, goes to make H2 gas plus 1/2 O2 gas, and the delta H equals, remember we got to change the sign because we got to reverse it because we reversed the reaction. Okay, now we have everything on the correct side. Water's on the, H2O is on the left, up here it's on the left, H2 is on the right of the arrow, up here it's also on the right of the arrow. But we don't have the right amounts. You notice H2O there and H2O there. There's two of them there and there's only one there. So what we're going to do now to get them so they're all the same is we're going to take this equation, we're going to times the whole equation by 2. So now we've got 2 H2O gas goes to make 2 H2 gas plus 2 times 1/2 is 1, so O2 gas delta H, now we've got to times that whole thing by 2, a positive 484 kilojoules. So now that matches up with our top equation. The next thing, we're going to add this first equation. We're going to add that first equation, and we're going to add our second equation. Now we're going to add those two together. I'm going to bring this, I'm just going to rewrite it and bring it right down here, right below this. So now we have carbon is a solid plus O2 gas goes to make CO2 gas. Delta H equals a negative 304 kilojoules. Okay, now here is the next concept. If you have oxygen, we're going to add all these together right here. And if oxygen is the same on the right side and the left side, it will cancel it out. It's like an algebra equation. You have x on the right and x on the right, 1. You just take them to the other side, you can cancel them out. So I'm going to start out by, they're both the same on the right and the left, so I'm going to leave that part out. So O2 and O2 is just going to cancel out. Okay, so I cancel those two out. Now, the next thing I'm going to do is I'm going to add them all together. I'm going to add everything on the left side. So on the left side, I've got 2 carbons. So I'm going to write carbon is a solid plus, I cancel out 2. The other thing, I've got 2 H2O gas on the left side. And then on the right side, I've got, this one wasn't canceled and that one wasn't canceled. So I've got CO2 gas, and I've got plus my, H2O, there's 2 H2Os, gas right there. Now, when I do that, I'm also going to add up my delta H. So my delta H equals 484 minus 304 is 180 kilojoules. Now, I'm going to go back, I'm going to check my equation. I'm going to make sure that everything's the same down here. So I've got carbon is 1 carbon there, I've got 1 carbon there. I've got 2 H2Os there, and I've got 2 H2Os there. On the right side, I've got 1 CO2 there, 1 CO2. I've got 2 H2Os and 2 H2Os there. That's correct. So this is the answer to our problem right there. Now, if the equation just says what is the enthalpy change, then that is the answer to the enthalpy change right there. And this is how you do problems with Hess's law.